Okay. Okay.
Okay. I'm on. Look at that. You're a moderator and you've got a sword. I forgot I
Oh,
set you up
cool.
like that. So, um, you probably have like boot or kick power or something.
Sweet.
Yeah. All right. So let's do some Rust programming, Adam.
Yeah, let's do it.
Okay. So switch over to this, and we've got cracking the coding interview, question 1.5, which is one away, where there are three types of edits that can be performed on strings: inserting, removing, or replacing. And given two, we should write a function to check if they are one edit or zero away.
Okay.
So we've got a couple of examples that they listed in the book, like pale and pull, because that's just one
So
deletion.
the first one is true because you can just add the A.
Mm-hmm.
The second one you can just add the S on the end.
Yep.
The third one you can change the P to a B, and then the other one's false because you'd have to change the P to the B and the L to a K.
Yep. Yeah.
That's
So
two
it's
edits.
just a bit too far. So
There are no examples where zero edits are required.
or zero edits are
Which,
required. Yeah.
yeah,
That would actually be a pretty good starting point, though, right?
yeah.
I mean, if we were able to check that, then I mean, we could even start with the simplest of simple, and we will say, I don't know, let's start off, and we'll do it in the true TDD fashion rather than like it it works. Um,
Right.
we we can, and I guess just so you know too, like this is just like a fresh cargo install aside from the comment up top. Like there's nothing, like there's no additional libraries or anything installed here. Just a like super basic
Okay.
repo. So um, if we start here, and let's say we were to um, assert, let's go and like find the distance even between something. We might step this up just a little bit further, rather than just saying like it is or it is not. Because I'm kind of curious like how many edits is it? Because if you know like how many it is, then telling whether it's 0 or 1.
Yeah, I don't know though, because some words are so different. How could you even say how many edits there are?
I I bet we could find a way.
Right.
So
But you would really want to find the least number of edits. And so that might involve deleting instead of changing or something like that.
right, yeah, I think we could pull this off though. And let's start off with like the most basic, and we'll see what we run into if it's a problem doing that, and if we need to fall back to true or false. But um, I think that we could do it for any count of them. Like, we are not the first to encounter this problem. So
No, it isn't a book.
yeah. So let's go and just say like let I don't know the length between um, uh, string length or distance. Yeah, distance. I like that distance. And let's say we even got the distance between like two strings, right?
Yeah, okay.
Let's let's work with that. And
So that one should be true.
oh, yeah, and we can even insert equal that like the distance between the two of those is or assert. We'll assert equals. The length of between the two of those is 0. Just for initial checking it. So we have it.
So to be clear, instead of writing the function they're asking for right now, you're writing one that's more specific, that's more powerful, and then we'll write another function later that uses this one that simply returns a true or false instead of the number.
Right. Yeah. I guess you could slight me in an interview for going a little bit beyond what we're supposed to do, but it'll be all right. So, we can start off this with making a function distance that and that will take a string that is A and a string that's B, and it will give a usize, which is just like an integer.
What's the public? Okay, public function distance.
Yes. So it just means it's public to the module.
What's the ampersand in front of string?
The ampersand in front of string?
Yeah.
So the ampersand is to say that it is a reference.
Okay.
My goodness. So to say that it is a string reference rather than a like actual owned string. So we can't go and like make changes to it because we don't have a mutable reference.
Right.
And we are mad because we don't have a usize coming out of this. So it's saying you're not returning anything. So
Right.
we'll start off with just giving it back a 0. And that should make it happy.
Is a usize a integer?
So yes. So a usize is an integer representing like the size of the structure. So it doesn't like it's kind of platform dependent. It could be 32, it could be 64. It's something that bits, like a integer that is 32 bits or 64 bits. But
okay.
Yeah, it represents the size of some structure, and because we're using strings, it's a good candidate to go with, because we're talking like in reference to the size of something or size of strings.
Yeah, makes sense.
Yeah. So and also like it doesn't go negative because
yeah,
you can't have negative size, so it forces that. So our test is now mad at us because it says distance is still not found in the scope. That's why we've got a nice squiggly right here. So if we go and use super, and then we just say everything from the parent above, do that, then we should wind up getting ourselves a nice first passing test. Doesn't test a whole lot, but it's something.
Right.
And we'll say like, we'll call it test empty, just to see like, does that work?
Yeah. So now we can do the same thing, but with two strings that are the same.
With two strings that are the same?
Yeah, two strings that are the same, but not empty.
Oh, yeah. I mean, we could potentially do that. And we'll get a pass here as well.
Okay, yeah. So maybe we shouldn't do that one. We should technically write a failing test for true TDD.
Yeah, because I mean, just to say test equal is that. So maybe
so we could do one where it's an insert or a delete.
Yeah, let's do it. So
from A to nothing or nothing to A.
Right. So let's do that, because the distance for this we know for a fact is 1.
Yeah.
I mean, So we could go and we could do something like, all right, if A is empty,
Yep.
then we're going to do something. And in this case, we'll return. We could return 1. I mean,
Yeah.
that's pretty hard coded, but then that fails for the first one. So we can't actually just say we want to return 1. So what if instead of that, in the
You can
handle,
check if B is empty, return 0.
I mean, we could even do the length of B, right?
Yeah.
Because if there's anything in B, then yeah, if we do that, let me save this thing. Now we have it working, and so we can even
Now
do
we need to go from A to nothing.
from yeah. So the other way around.
Yep.
What if we even did this just for like? I mean, it doesn't really matter, but what if I swap it for B?
Sure.
I mean, and then this one, yeah, we say A is right there, and so instead of test equal, empty A. And
Yeah.
then change this one to empty B. Okay, so once again.
So now what we could do is get the length of A and the length of B and subtract them, and return the absolute value of that.
So the length of A and the length of B.
Yeah. Yeah.
Oh.
Subtract the length of A from this length of B.
All right. So, well,
And then get the absolute value, so it's positive.
that actually will give us an interesting problem. So if we were to go and do that, and what is it? What? The stocks. Yeah, I'm gonna even go pop this because to go and get absolute value, it's been a little bit. Because if we did that, and then we'll actually get a panic because we attempted to subtract with overflow. So that's going to be a problem because A.length is a U size and B.length is a U size. And
Okay.
you can't subtract one from the other. Sorry, you can't go to the negative. Like, that is a runtime panic.
Yeah. Can you convert them to ints before you do the subtraction?
What if we were to go and just do the inverse of this check?
Yeah.
Just because, yeah, I mean, it is definitely possible to convert them.
I think that's going to fail the first test. No? Okay.
Oh, because if A is empty, then we get the length of B, and if B is empty, then we get the return of A.
Oh, so you don't even need that 0 on the end.
Well, if they both have something, then
If they both have something, you're going to get 0.
right. Like, I don't even think that this will compile because it'll
Oh,
yell
yeah.
at me and like,
Right.
yeah, expected something found U size. So
Okay.
yeah, we've got to have a 0 there because it's possible for A and B to both not be empty.
So I think what will fail it now is if we go from A to B.
So if we go,
That will return 0, but it should return 1.
oh yeah, yeah. So if we do like that,
Yeah.
I don't know what that would be. Mismatch 1, I guess.
Sure.
There we go. All right. So, yeah, let's figure out then.
We could do if the length of them A and B are equal, then just compare the strings, and if they're not equal, return 1.
Okay. So I mean, we could even do like if A triple equals too much JavaScript.
Yeah.
A equals B. If A equals a B, then there's no difference, and we're good. I mean, that could even come earlier. But,
Okay.
and then
And then return 1 at.
yeah, why not? Let's do it. Boom. Got this interview in the bag.
The only thing you're proving is a little Rust and TDD. Not that you can actually solve this problem.
Well, I guess this isn't like a full-on interview, but more just solving a problem. But it is true. We've just played with Rust. But hey, I mean that's got some hype factor to it on its own, right?
Yeah.
That we can do that. I mean, it can be a talking point of like, why would you choose that? And so, either way, let's go and like, let's be really. All right, so, here we go. So let's say that we have a mismatch of length. So let's do insertion.
Okay.
We're gonna go all in on this thing.
Does that fail?
Well, the length of this, yeah, the length should be 1. So let's see if this.
It passes because it's a difference.
Oh. Okay, let's make this thing fail.
Yeah, it's because we're returning 1 at the end. Wait.
Oh yeah, so this one's 2. So our assertion was bad. I was gonna say this one should definitely fail.
Yeah, because we're returning 1 at the end.
Yeah, we have no case that we're returning 2. Well, I guess if the length is different, right?
Yeah. If one of them is empty, it would return the length of the other one. But
right. So let's see if we.
Okay, so we need to handle the case where neither of them are empty, and they're not equal to each other.
Right. Neither of them empty, not equal to each other. So if we were to go and do that, then like any classic interview problem, let's use recursion. Right? Like if we were to go and go down that route.
Okay, yeah.
We could probably go and work it from there. Like if we call distance, but we go and we find out that let's see. Hi. Oh. Okay. Okay. Sorry about that.
It's all right.
So, if we went and let's say we went and changed this really quick, because I think I know what to do on a specific case where they are equal length, but both different. But we can do it with more than a single character. Because if we go and we strip, like if we go and we compare characters and then we iterate through them together, then one of them's going to zero out before the other one, right? Yeah, well, I mean, let's try it. So if we go and we say, like if we were to go and call distance again, like recursing on itself.
Yep.
and we went and we did it without the first character. So let's say like we were to compare the first character before. And so both of them or something like that. Then, or my mistake, other way around. So skipping over like the first character, and then iterating through this again. Then we'd be moving through the strings and like looking at the characters together.
Wait, so you're passing both strings in again without the first character?
Yes. So I guess we'd need to find one other thing, is like do the characters match, right?
I thought maybe what you would do is remove a character off of the longer string.
Okay. If we remove the characters
I thought maybe you'd remove the character off of the longer string.
off of the longer one.
Yeah.
Maybe. Let's see. Just thinking through this. So if we were to go and remove it, we can remove the character. I mean, we can run the test, of course, but
Because you need to. So if they're not equal length string, you either need to add characters to the shorter one or remove characters from the longer one.
mm-hmm.
And then after that, you might have to change some. But thinking of this as an interview question, we don't ever want to do more than 2 changes. So all we want to really do is see, are they exactly equal? Okay, cool. True. If we were doing the other function instead of the distance function.
Right.
Okay, are they equal? Cool. Can we add a letter to one of them and make it the same? Cool.
Mm-hmm.
Can we remove a letter from one of them? Cool. And then can we just change one letter?
Right.
So I think that's going to be a lot simpler than trying to count the number of changes required for any 2 strings.
I think that we can do this though, because
Okay.
there is what is it called? There is a pretty hip thing that somebody thought about way before us called the Levenstein distance.
Okay.
And it is a way to measure the distance between 2 sequences. And distance being like the number of insertions, deletions, or substitutions. That sounds very much like what we're looking for.
Exactly.
Yeah. And so,
Okay.
so it
So
is.
we're changing the problem, but I
Yes.
like it.
But yeah, I guess having like greater context for it, for the specific problem, I don't know, I guess shows awareness, right?
Sure.
So, let's see.
And if you could just pull Levenstein distance out of your hat in the middle of an interview,
Exactly. So,
props. Unless you were just like, that's the only thing you know,
right,
and the question they asked was close enough that you could try to use it.
right. Yeah, it is a talking point. So, let's see. If we were to go and do this, then because what the Levenstein distance does, I guess I'll go and pull that back over because they have like a mathy like formula.
Wow.
So they go and they actually find out what the minimum is using like by recursing back over. So finding the maximum between I and j. So like you don't iterate more than I or j, which makes sense, right? Because you don't want to iterate longer than any one string.
Yeah.
And then what you would find is the minimum between removing the first one off of I. So like I guess in our case it would be A. So removing the first character off of A, and then the remainder of B. Or in the inverse of it would be removing a character from B but not from A and adding one, because both of those would be considered, I think they're like insertions, right? Or deletions. I don't know. They're
Sounds like a deletion.
Yeah, so I guess it would be a deletion necessary for it. Or the third option is removing one from each of them, but if they're not equal, then you add one.
Oh, it says it right down there. The first one we subtract from I is a deletion. The second one is an insertion.
Okay, yeah.
Because you'd have to insert on to the first string. And then the third is a mismatch.
Mm-hmm. Yeah. Okay. So
cool.
I guess we're doing the third one, which I think will be, I don't know, maybe we have to have like equal length for that and for it to work out. I don't know, we'll see. But we need to add one if they're not equal. That is a pretty key part. Is if A of I not equal to B of I, then we add one. Because if the characters are the same, like there's no distance there, right? We just need to keep iterating from that point. So if we say, if we let our cost, we don't have to return anymore. If A, we need the first character of A. So in Rust, in other languages you would do this.
Yeah.
But this is a Rust point where else, I think, say 1, then...
Is this a ternary?
Yes, because Rust does not have...
Okay.
So...
Is it called a ternary? Or is it just that the if statement can be an expression?
If statements are an expression, they don't call it a ternary. So let's see. Expected. Oh, so it is mad that we're calling distance on that value. So okay, so now we get a lengthy error from Rust to say string indices are ranges of U size. So what Rust is really mad about is that if you try and index into a string, you can't, because characters within a string are not necessarily a fixed size. If that makes sense.
Like Unicode?
So yeah, like, so indexing in, like, are you referring to the first byte or you're referring to the first character?
Right.
And so instead of doing this, you need to get the characters, which gives you back an iterator over the characters. And then since we only want the first character, there's nth.
Nth? They don't have first?
They don't have first, no. Nth, I mean, is just universal, so.
Yeah.
B dot.
I'll be right back.
Sure.
Okay, I'm back.
Welcome back. Okay, so where we were at just prior was we were comparing the first character, and if they're the same, then there's no cost to it. Otherwise, we have a cost of 1. And then we needed to go and add that because it was yelling at me that it didn't use cost, which makes sense.
Okay.
So
Yeah.
if I go and save that, then we're passing our tests.
Okay.
So
That's cool.
yeah, so from here, I mean, if first one's empty, then we give it the second's length, and the inverse of that as well. And then we go and, like, if neither of them are empty, which are, I guess these would be like our 2 base cases, right?
Yeah.
Then our other case is we start looking at characters and comparing them. So we've got that, but let's look at some of their other examples too, because this doesn't, I mean, it doesn't cover all the cases in the Levenstein distance, because if you
Right.
recall, it was talking about getting the minimum of some other things as well. Of like,
Yeah.
so let's say for example, if we were to have like one kind of in the middle case messed up. So I mean, you can even take one of theirs from like pale and bake, because this one's a distance of 2 as well.
So, yeah, it looks like we're only calling distance with the change. I thought we weren't covering the insertion and deletion.
Yeah. I think part of it is because the difference between, or like, these are both not the same. So if we were to go and test another one, they gave the example of kitten and sitting.
Sitting.
Oh.
Oh, sitting. Yeah. Okay.
Yeah. So let's try kitten and sitting, because that is 3.
Yeah.
I don't know if that's really the best test name for it, but I don't know. Right, kitten and sitting.
So this one involves insertion and changing.
Insertion, yep, and changing. So this one's got a distance of 3. Well, that one passed too.
Interesting.
That is interesting.
Try the ABC. Try the opposite of that.
Try the opposite of it? Well, we're going over them together. So, let's see. So, like this way?
Yeah, ABC to A should be deletion of 2.
Yeah, I mean, that one passed. What if we were to do,
I don't
like,
see
not...
the... Oh, is it alphabetizing a test? Wait.
There we go.
Ah.
So, here's a case. 'Cause I was going to say, there's got to be another one that we go and put it to the test. And so, like, this one, for example, I mean, the distance is only 2.
Yeah. And what's it returning?
It says that it's 3. Because it's saying the first one doesn't match, and then it's saying the second one doesn't match, and then it's saying the third one doesn't match. So it's not accounting for the case that it is the same.
it's deleting A, it's deleting B, and then changing C to B.
Right. So it's doing all three of those, which is not optimal.
Right.
So now we have a case that we need to go and test something else. Testing, we need the minimum of, we either need to do this one, which is going over them together, which is, I guess that would be a change, right? That
Yeah.
it's mainly accounting for, that it's accounting for. But then we also need to handle deletion. So in that case, we need to say that we want to have A without everything else, but we're going to give it the remainder of B.
Yeah.
And then the cost of that is always a 1.
Okay.
Because deletion has a cost. So regardless of whether the letters match or not, it doesn't really matter. And if I save that, then it will format it. And oh yeah, I need to have standard compare min. So use. Thanks for being helpful, Rust compiler. There we go. We got a min. Okay. So that's one of the ways. And then we also need to handle like insertion as well, right? So,
Yeah.
which would be the
So,
opposite of this, right?
Yeah.
So from B, or sorry, yeah, I guess we can start with B. B to A, B, C. Then once again, this should be a distance of 2.
And it's probably going to say 3.
That's what I would expect, because that's what our default one was doing before. Because the best that it knows how to do is
doing a delete, and a change. Yeah.
Right.
Or an insert.
Mm-hmm. So in that case, we need another min.
Can you? Oh, you can't.
You can't what?
You can't min 3 things. It just takes 2.
Yep. Min is fixed. So we can't min 3 things. I mean, we could go and like allocate a vector and go and do that, but I mean, this'll work as well.
Yeah.
So in this case, it is a distance again, and we want to have A. We're going to give it the full A because we need to insert something. So insertion onto A would be the equivalent of going and trimming 1 off of B, and then adding 1 because that is the cost of that.
Yep.
And then I did something wrong.
You need a closing parentheses at the end.
That. Yep. Unclose the. Thanks. Thanks for reading my error message.
I actually didn't, but
oh well, yeah, I think it told me what to do there too, because it said unclose delimiter. Yeah.
Yeah.
So.
Min.
Okay. Do that. Now we're good.
We're good.
So let's go ahead and test the original theory. Or not original theory, but like the original problem. Just to get back from it, to take our overpowered version of this and bring it back down to these.
Yeah.
And so if we do another test, test FN, I think it is. Thought I had one.
A snippet?
I did. I made a test snippet for Rust because writing test functions is common enough. So now I can go and make a function like I don't know, I should be doing this TDD. So if I say, assert that too far, pale, and PLE. So, or not far, or so close. Right? Because that's what they want us to assert. We want to assert that that's close. And we'll start with that.
Should be, oh,
What's that?
okay. So all you have to do is assert $, and that's a function that's just looking for truthiness.
Oh, so yeah,
Or it's just looking for it that is true.
Yeah, so assert is it is actually a macro. Anytime you see an exclamation mark, that's actually a macro in Rest. So they go and they do some other fanciness to make it print well, but it works like a function.
Ah.
I don't know what it actually decompiles down to, but yeah, just know that when you see that.
So close will just return
true or false.
Length less than 2.
Mm-hmm. Yep. I guess I'll let it fail first.
Or distance less than 2.
Yep. So close is not found in the scope. And then the other part, oh, it's mad because this is document, or that's module level comments inside of that.
Oh, okay.
That's so / exclamation indicates that it is like module level comments, because it will actually produce documentation based on that. So that's why that was mad. Makes sense. So pub function close, and that one is A and B, and then give me a rule. I don't know why it's working so hard. Am I freezing up?
Yeah.
Oh, you can at least still hear me, which is good. But
yeah,
I don't know what the deal is.
Yeah, the last thing you typed was the arrow. Okay, now I see it. B. Ooh.
There it goes. Yeah, it like restarted. Weird. It's like messed up.
Your terminal is messed up?
Yep.
I've had issues with VS Code terminal.
I typically only use VS Code when doing this. So when doing Rust stuff, so cargo, watch, quiet, execute, test, quiet, test. I think that's it. There we go. Okay. So and true for the moment. Say that we're going to that, and close is in the scope, which we're good. We're passing on that right now, which is fine.
Let's get that false one in there.
Yeah. And yeah, we'll do that one too.
Yeah. How do you need to assert that as false though? Okay.
There we go. Now test it works. Yeah, I guess test it works is fine for actually that one.
Yeah.
Default test names.
It does the right thing.
It does. Yeah, it does the thing that it's supposed to. That's what all tests assert. All right.
It tells you if it's close.
Distance of A
B.
and B
Less than 2.
Or greater than 1. Because it won't ever be negative.
But you want the. If it's greater than 1, we should be testing that it's less than 2. Yeah.
Oh, yeah.
We want to know if it's close.
Right. Yeah, not too far. I was thinking in too far again, but there you go. So
all of these should pass.
yeah, I would expect them to, but we'll handle insertions as well.
Yeah.
And pale and bale.
I feel like they missed an opportunity to do pale ale.
They did. Maybe
Because that pale ale would be an example of deleting from the beginning of a string, which they don't have.
right. Yeah, they don't have.
Well, I think that's one of the things is they never give you all of the test cases. You're supposed to come up with some on your own.
Oh,
It doesn't even give you the most basic case of 2 empty strings, or one of them being an empty string.
right. Yeah, I mean, I guess that's what you're supposed to be presenting in the interview is thinking about like the simple base cases and then working up to those, not
Yeah.
necessarily solving those ones immediately. But
Yep.
there we did it. We
Can you do pale ale? Because I think that one's cool.
yeah. We'll do some pale ale. And that is close because it's just a deletion.
Yeah.
And we're accounting for it with our Levenstein distance.
So it is a one-line function.
With the utility function that is
Yeah. It's
Yeah.
a one-line function with a utility function.
right. Yeah, just pull out your Levenstein distance. I'm sure like if you're using Python, they have the thing.
They
Yeah.
probably just have a Levenstein distance function built in.
Right. Well, not necessarily built in, but like I don't know, like SciPy or one of those or NumPy would have something like that built in,
Okay.
right?
Maybe.
And there was further that I didn't dig into here, but they talked about the actually taking like this sort of approach is it's not efficient because it recomputes for like the same substring a whole bunch of times.
Yeah.
And so you can actually do it in like a matrix sort of form. And taking that sort of approach. I haven't messed with that, but it seems like an interesting way to go and like reuse existing calculations.
Oh, interesting.
Yeah. I would.
Yeah, I can see where the duplication would occur
Mm-hmm.
because it's just like a multiplication table. You're gonna see the same things over and over.
Mm-hmm. Yeah.
Huh.
And they even bring up like the fact that that you don't even need to have like the whole thing. You can do it with just 2 rows at a time.
Wait a second. So the part where it's a change and then we're calculating the cost. Why is that? Why is that not just a cost of 1?
Say that again. Oh, right here.
Yes, that cost.
So if you have strings A, B, and C and they're equal, but they're not empty, because we're accounting for empty in our base cases, right?
Oh, okay.
Yeah. So
We're doing the cost of 0 or 1. I get it.
Yep.
It looked like in that Wikipedia article, they've got different numbers there, like 6 and 5. Is that the distance between those 2 letters in the alphabet?
Oh, right here.
Yeah.
So what they wind up doing with the matrix, I mean, when they initially go and build the thing out, it's to say, against the string of 0 length. If you were to go, because this is empty string in this
Oh,
leftmost corner, then it's a distance of 6.
because insert K is 1, insert I is 2.
Mm-hmm.
Okay.
Right. So 0 and 0 is that, but from S to an empty is 1 because that's a deletion, but
Mhm.
also S to a K is 1 because that's a change.
Yeah.
So um, that that is how it gets built up.
Okay, cool.
Yeah. And then there was something that said it talked about this Hirschberg algorithm that combines it with divide and conquer,
Hmm.
and it is supposed to be a better, or potentially a better approach. I mean, divide and conquer, we always like that, right?
Yeah.
Yeah, but I didn't
So
take
I
the.
feel like the next step would be to take any string,
Mm-hmm.
and if it's not a word, guess what word they're trying to type.
Yeah, and that is what this is used for, actually. Is to go and or at least commonly used for is to go and like make suggestions.
Yeah.
So that would be kind of a good like personal follow up is using like the user share dict folder that is built into lots of systems.
Okay.
So
Yeah.
I don't know what is it. Uh,
Proper names,
Words. Yeah, there we go.
words.
Yeah. So this thing, like going
Yeah.
and finding one that is close to that would be
Yeah.
um yeah, I don't know. I don't know. You'd have to find something that was
You'd want a better
right.
structure,
Yeah,
data structure than just an alphabetized list.
yeah. I mean, I guess you would want to, um, yeah, because just working off of an alphabetized list, I mean, you could you could go and do things like looking at like length to go and use as like an initial heuristic to say like, okay, the length of like just the length of these is significantly different. And so
Yeah.
because of that, it's unlikely that they're referring to the same word.
Yeah. Huh.
I I would yeah, I'd have to see on playing with that. But anyway, this one was a fun exercise,
Yeah.
and I do have a number of other ones that we could do at another time in the future. Of other cracking the coding interview ones, I think I've got like O dot or 1.1 to 1.9 done, so we could go and do more of these
Sweet.
if you're interested.
And I don't remember what chapter 1 is all about. Is that just is
Uh,
that string manipulation?
I I don't know. I mean, a lot of them are very string heavy,
Yeah,
which is
it might be.
so it might be strings. It might be like
Might be data structures.
yeah, maybe that's it. But I mean, I guess I didn't really have to make a particular data structure in this one, so it might be another one. But
Yeah.
either way, there are a lot of problems to work through, and they're kind of fun to look at, especially when you go and can find somebody who's made like a really efficient algorithm. So like going
Yeah.
and like taking an initial stab is kind of fun, but then to go and see like is there a more optimal way of doing it? And while it isn't necessary for the interview, I mean at the same time it like if you have kind of that little piece of knowledge, like even if you can't remember
Yeah.
exactly what it was, if you're like, "Oh yeah, there's that." I
Yeah.
mean, like
Because I was looking through the algorithm design handbook one time, and I didn't get very far into it. but it's just fascinating when you come across some of these algorithms. One of them was how to find a string within another string.
Mm-hmm.
So probably you're looking for a word, but within an entire passage.
Mm-hmm.
And so how do you do that efficiently? And what they do is you look at the string, the length of the word that you're searching for,
Mm-hmm.
and you go and you hash that word, and then you go to the passage and you hash every single bit of characters that's that length.
Hmm.
So you hash if the word's 1 to 5, you hash from 1 to 5, and you hash from 2 to 6, and you hash from
Yeah.
4 to 7, and then all you do is look it up in a hash table.
Interesting. Yeah, and you could even do like optimizing things as well. Like if you didn't want to necessarily store all of them in one place,
Mhm.
you could do like a bloom filter, and
Mm.
that would be a fun structure to implement too. So a bloom filter is like hashes on top of hashes.
Uh,
So you take your hash of like substring 1 in your major string, and then you take the hash of substring 2 in there, like within the main, and you do all like 100 substrings or however many you need to do, and you can apply it to the same set of bits, and then by using that you can go and hash your stuff, or like hash your input against it to see like um, does this thing contain it, and it will never give you a false positive. So with a bloom filter, like you still do have to do a lookup ultimately to find it, but like if you just want to search if something includes it at a really
yeah,
fast
you
speed,
can get false negatives. So as long as you're okay with that.
yeah, like um, so like it may say, well, it's possibly in here. You need to check, but it's never going to say
Yeah.
that it's not in here when it in fact is. So if that's
You
what
might
you're
not have to check. You might not care.
right. So that would be kind of a fun thing to go and implement too. I have not done that in a long time, and I have never done it in Rust, and so that is another challenge to throw on the list. But either
Yeah.
way, that is it for this time. It's been fun, and yeah, we'll have to do it again sometime soon.
Yeah. Sounds good.
So I'll hit stop.